Okay, we're going to be graphing systems of inequalities, and basically that just means we're going to be graphing each one of these equations and shading the certain areas, and then the areas that they are both shaded in is going to be your solution. So we're going to take one equation at a time. So if we've got x is greater than 5, remember that's a vex, so it's a vertical line at x is equal to 5. And so let's go. Let's graph that. It's not equal to that, so it's going to be a dashed line.
I don't know where they got that because
and it is greater than, so we're going to shade this side of the line because it's greater than. Okay, now I'm going to do the other one in a different color. So we've got y is less than or equal to 4. Remember, that's a hoi, so it's a horizontal line at y is equal to 4. So 1, 2, 3, 4. We're going to graph that. So this one is also equal to, because that line is underneath it. So we're going to make a solid line and graph it. And it is less than, so we shade below the line, so that's all of this area. Now your solution set is the area where both of them are shaded, which is going to be this area over here, would be your solution set. So when you're doing these, make sure that you either use 2 different colored pencils and shade those in so that we can see exactly where that shaded area is of the 2 equations that is your solution set. Okay, don't just shade both of them and expect me to know that. I want you to show me that you can determine which is both shaded from both lines, and that's your solution set. Okay, so let's go to number 2. Remember, in order to graph these, they all need to be in that y equals mx plus b format. This one is, so y is less than or equal to 2x plus 3, which means that y-intercept is at 3. And you have a slope of 2, so that means up 2 over 1. And it's going to be a solid line because it's also equal to that. And we will shade below the line because it is less than. Okay, so let's go do that. Shade it. Put it point at 3, or y-intercept. And we've got a slope of 2, so it's up 2 over 1. Up 2 over 1. Down 2. So we've got a solid line here. And we are shading below it. So that's all of this area. Just notice I don't shade real heavy until we know for sure what is the solution set. So y is less than negative x plus 1. That means we've got a y-intercept at 1 and a slope of negative 1. So that means down 1 over 1. This one will be a dashed line because it is not equal to it. And again, we're going to shade below the line because it is less than. Down 1 over 1, all the way through. Dashed line. And it is below the line, so it's this area here. So the area where they are both shaded is our solution set, which is this area. That area only. So ordered pairs that are within this pink area will be your solution. So these are not in y equals mx plus b, so we're going to make sure we put them in y equals mx plus b before we graph them. We're going to subtract that x over. So 2y is less than negative x plus 6, and you all should know how to do this. We've been doing it for a while now. So y is less than negative 1/2 x plus 3. So we've got a y-intercept at 3. Slope of negative 1/2, and it's only less than, So dashed line, and since it's less than, we're going to shade below the line. Down 1 over 2, down 1 over 2, 2, dashed line, and shading below, so that would be this area. Let's look at our other equation. 3x minus y is less than 4. Look at that in y equals mx plus b. So negative y is less than negative 3x plus 4. Dividing through by negative 1, which is a big sign to flip your inequality sign when you divide through by a negative number. So now y is greater than, that makes positive x minus 4, positive 3x. So our y-intercept is at negative 4. We have a slope of 3, which is up 3 over 1. This is also going to be a dashed line because it is just greater than, not also equal to, and we will shade above the line because it's greater than. So we're going to start at negative 4, up 3 over 1, up 3 over 1, up 3 over 1, put a few points over here, dash line through those, and it is above the line, so that would be this area. And our solution set again is where they are both shaded, which is this whole area right here, only this area. Okay, one more example here. Just doing the same thing. 2x plus y is greater than or equal to 4. We're subtracting our 2x over. So y is greater than or equal to negative 2x plus 4. That means we've got that y-intercept at 4. Our slope is negative 2, so negative 2 over 1. That will be a solid line because it's also equal to, greater than or equal to, and we're going to shade above the line because it's greater than. So let's draw that one. Solid line through all those points. And it's greater than, so we're shading above. Let's look at the other equation. 3x minus y is less than or equal to 6. Subtract our 3x over to the other side. Divide through by negative 1, which reminds us to flip our sign since we're dividing by a negative. So y is now greater than or equal to 3x minus 6. So we have that y-intercept at 6, negative 6, and a slope of up 3 over 1. And that will also be a solid line since it's also equal to, and we're going to shade above the line. Negative 6, 3 over 1. Solid line. And we're shading above the line, which is this area. And so solution set is only this little area here. Okay, so to find points that are in the solution, you've got to find them points that are in this pink part. So points in the solution would be like 2, 2, that point right there. There is a point that is a solution. You could say 1, 1, 5 would also be in the solution set. That would be about right there. Then we could say 3, 3, 6. When you're doing that, I wouldn't put anything that's close to the line, just make sure you're way up in there. So points then that are not in the solution would be anything that's outside that pink area. So 0, 0, -2, -5, or 5, 1. So none of those you see are in the pink area, so none of those are in your solution set. So hopefully that helps you.